Welcome once again to the April 1st video highlights for AJP-Heart and Circulatory Physiology, or from the editor's desk. We will give you a smattering of what's new and noteworthy in this week's issue. So let's get going. So you want to know about lymphatic endothelial cells? Everyone does. Jafaranajad et al. Measured changes in intracellular calcium in human lymphatic endothelial cells under various shear stress. Increases in shear stress increase the Fura-2 calcium signal. These authors concluded that shear stress-mediated calcium signals are dependent on the magnitude of the shear stress and involves both stored calcium release as well as extracellular calcium entry. Costa et al. Determined the effects of testosterone associated with estrogen on vascular function in a model of hypertensive postmenopausal ovariectomized spontaneously hypertensive rats. Using aortic rings, they examined angiotensin II-induced contraction in 4 groups of rats with and without estrogen or estrogen plus testosterone. The role of oxidative stress in angiotensin II-induced contraction was also investigated. The authors found that the association of testosterone with estrogen impairs the benefits of estrogen on overectomized associated endothelial dysfunction and ROS generation. This occurred by a mechanism that involved phosphorylation of cytosolic NADPH oxidase subunit P47-FOX. These data have importance for the addition of testosterone to estrogen in postmenopausal women to prevent sexual dysfunction. It has been proposed that low levels of chronic carbon monoxide exposure may impact mortality and morbidity of cardiovascular diseases. Meyer and co-workers investigated the role of inducible nitric oxide synthesis on ischemic myocardial injury in response to low levels of carbon monoxide exposure. Ischemia reperfusion injury in isolated hearts were examined in the presence of an INOS inhibitor following carbon monoxide exposure. Carbon monoxide exposure altered the pattern of INOS expression and INOS inhibition, reduced infarct size following ischemia reperfusion injury. This study has profound relevance to air pollution-related cardiovascular disease. Thank you for watching this week's highlights. There's much more at ajpheart.physiology.org. Check it out and don't forget to send us your best work now. See you next week.